All right, guys, this is 10-4 solving radical equations. So kind of similar to what we did last chapter when we were taking the square root of each side to get rid of the squaring. Now we're going to square each side to get rid of the square root. A radical equation is anything with a variable under a radical. It's an equation with a variable under a radical. And one thing we do need to watch out for when we square each side to solve a radical equation is that we could introduce what are called extraneous solutions, and that's just an answer that doesn't work or satisfy the original equation. It doesn't work in the original. So we're going to need to plug in and check it, and I'll show you what I mean here. So here's a couple of simple ones to start with. First thing we're going to do is isolate the radical. So we can subtract 7 from each side here. And then to get rid of the radical, we're going to square each side. It looks like this. So we get x equals 81. We can take that 81, plug it in right here. Square root of 81 plus 7, does that equal 16 is the question. And square root of 81 is 9. 9 plus 7 does equal 16. So that solution checks out. So just get in the habit of checking your solution. Same thing over here. Add 5. Square each side. So x equals 9. And if you plug in the 9 there, square root of 9 minus 5, verify that that equals -2. So there's one where you have to first isolate the radical before squaring each side. All right, next one is a real life sort of problem. We've got, it says the time it takes the pendulum of a clock to complete a full swing is approximated by this equation where t is time, L is the length of the pendulum in feet. If the pendulum completes a full swing in 3 seconds, how long is the pendulum to the nearest foot? So we can plug in 3 here for the time, t. And this one, once again, we've got to isolate the radical by this time dividing by 2. So I have 3/2 equals square root of L over 3.3. If I square each side of the equation here, I get 9/4 equals L over 3.3. And what you see is a proportion here. I can cross multiply. So I've got 4L equals 29.7. When I divide by 4, L ends up equaling about 7.425, or we'll just say L equals 7 feet to the nearest foot. Real life sort of equation. That one we got to divide each side in order to isolate the radical. So each of the first 2 examples, you had to isolate the radical first before squaring and solving. This one right here, we have a radical on each side. So we can go directly to squaring each side of the equation. It looks like this. Removes the radical on each side, leaving us with a pretty simple one variable linear equation. We've got variables on both sides. So we're going to get the variable onto the one side here. And then add 11 over. So 4x equals 16. Divide the 4x by 4 and the 16 by 4, so x equals 4. If you plug in 4 here, find that 20 minus 11 is root 9, and here 4 plus 5 is also root 9. So it looks like that x equals 4 works. You can try the next one on your own. Maybe pause the video. Check and see if you get the same thing I get. Should get x equals 7 on that one. Just one more to do. Pretty short lesson here. Once again, that's one where we have radicals on both sides. You just square each side and you've got it. This last one, a couple examples in which we have extraneous solutions. So you'll see that when I go to solve this, I'll have at least one solution that doesn't work in the original. So here we square each side to get rid of the radical. What that creates is a quadratic trinomial. We solve that by setting it equal to 0 and factoring. We're looking for factors of a times c. Remember, a is an unwritten 1 here. C is -12. A times C is negative 12 that add to equal B. B is negative 1. So negative 4 and 3 will work, giving me factors of x minus 4, x plus 3 equal to 0. Setting x minus 4 equal to 0 gives me x equals 4 as a potential solution, or x plus 3 equals 0, and x equals negative 3 is the other potential solution. So we've got to take both of those and plug them into the original. So if you go back up here, erase the squaring up here, if you plug in the 4 up here, right here and here, 4 plus 12 is 16, square root of 16 is 4, so that one works. We can box the x equals 4. And when we go to plug in the negative 3, something different happens here. Here, put in negative 3 here, negative 3 here. Negative 3 plus 12 is 9. Square root of 9 is positive 3, and positive 3 does not equal negative 3, so we call that extraneous. And we'll just cross out that potential solution and only box x equals 4. Right, the second one here, we're going to subtract 8 from each side. So we've got square root of 3x equals negative 6. Square each side, and what you'll see is when I go to square this negative 6, I have an issue here. So 3x equals 36, divide 3 on each side, x equals 12. If you go back in here, square root of 3 times 12 plus 8, does that equal 2? Square root of 36 is 6. 6 plus 8 is 14, which does not equal 2. So the one potential solution does not work. So we would say there is no solution to this radical equation. All right, so maybe try the last two on here. They fall into similar categories as these. And don't forget to write your summary. All right, hope this helped.